Hello everyone. Welcome to today's webinar on running stateful containers on Amazon ECS. Today we have Shubhranshu Sarkar, who's a senior technical account manager with AWS, and Francis Pereira, who's the head of infrastructure with CleverTap. Please note, during the webinar, we do have a Q&A available, live Q&A available for you. So if you have any questions, feel free to pop them up in the Q&A chat. Thank you. Over to you, Shubhu.
Am I audible? Okay. Hello, everybody. Good afternoon if you're in India. We'll start. So my name is Subbu, and I will be covering best practices with ECS in the beginning of this presentation. I'll hand it over to Francis for covering stateful containers with ECS, and then we'll wrap up with some other best practices from customers and with a Q&A. So to start with, why containers? Now, containers typically bring speed to your development because containers, to start with, they can be brought up pretty fast, right? Because containers are not having a separate kernel from the host operating system. It shares the kernel. It can be brought up pretty fast. They are very efficient in a sense that you can actually stack up a lot of containers by using something like bin pack on ECS to optimize a lot of EC2 instances. You can reduce your number of EC2 instances. It's extremely easy to pack your application inside a Docker container. And it actually gives a very good developer experience because the same container can actually now travel through your test and dev environment till your production without any change. And you can be rest assured that if your container has run on your laptop, it will run the same way on the production environment also. It is less risky to deploy containers because in containers we follow the immutability of infrastructure and the code. So you actually don't go inside a container and change much. The container remains as it is throughout its life cycle. But the real application for containers is mostly in the microservices area because monoliths are now getting broken down into smaller services. And each monolith, for example, can be broken down into 20 or 30 microservices. And these microservices will have their independent pipelines for them to be deployed. So, and these microservices are interdependent at times. And that's why you need a very efficient networking between them, a communication mechanism to reduce the latency as much as possible. Moreover, many of these microservices are actually written in modern languages like Node.js or Python, in which inherently there is no packaging mechanism like you have jar for Java. And that's why container actually helps you in that aspect also to package the microservices. So now, as long as your containers are restricted to a small number, it's okay. But what happens when your container, you are using containers at scale, when you have 1,000 or 2,000 containers representing your services, why it is difficult to manage them? First point is they are more transient. Containers are typically used for short-lived processes. So they appear, they do their job, and then they disappear. It's extremely difficult to track them if you do not have, if you do not have a proper mechanism to manage the containers. They are more distributed. By nature, these things are supposed to be deployed on various nodes running in various availability zone, for example, and you need a distributed networking to let the container talk to each other, right? And you also need a very sophisticated scheduling mechanism to allow your containers to be launched on EC2 instances where you want them to be. Very important, since the containers actually use the same kernel of the host on which they are launched, you are actually dependent on security features which are actually given to you by the Linux kernel to have that isolation needed yeah, in between containers. So it is very important for you to make sure that the underlying host is patched and secured and hardened so that containers cannot affect each other. And that is why it's very important to have a orchestration tool which can manage the hosts as well as the containers. This talk is about how AWS has helped with these challenges. I'll go a little bit into the AWS container strategy. Right now, you have two great orchestration tools from AWS. One is ECS and one is EKS. And both of them comes with two deploying mechanisms. You can actually let the user bring their own EC2 instances, and you can have them host their containers on those EC2 instances, or you can actually manage the EC2 instances for them. So the first one is called the EC2 mode, and the second one EC2 launching mode, and second one is called the Fargate. So Fargate is the one where you can actually let AWS manage your EC2 instances for you. You just have to bring your containers and run on them. Fargate with EKS is not yet available. It will be available soon. Today we are going to talk mainly about ECS. So here is the agenda for today. We will have a brief introduction to ECS, best practices, best practice patterns and strategies for scale. We'll hear from CleverTap, who is a local company in Mumbai, and if time permits, we'll have some other case studies. Along with this, we'll have a small demo from CleverTap as well. Brief introduction to ECS. So what is ECS? ECS is actually a managed service to manage your containers. It is a fully managed service. It is scalable and highly available. It actually lets you manage your microservices, your batch workloads, your machine learning applications, and it is very well integrated with rest of the platform. It is integrated with things like Amazon Elastic Container Registry, ECR. It is integrated with AWS networking, storage, management tools, and AWS Fargate. Just to mention, Fargate is not a separate service. Fargate is a way of launching your containers in either ECS or in future in EKS also. So here is how the ECS constructs actually look. So in ECS, you have the cluster, which is a cluster of EC2 instances. EC2 instances, when they register into a ECS cluster, they are called container instances. Each container instance will have its own ECS agent, which communicates the status of the cluster to the ECS control plane. And you have to bring your Docker containers, and then these Docker containers actually run as tasks, which is the most granular thing you can touch in ECS. A task can have one or more containers running in a sidecar pattern. You also have a very good load balancer integration with ECS. You can have either your classic ELBs, ALBs, or NLBs integrated with ECS, and each service typically is represented by a target group of a ALB, application load balancer in ECS. Why ECS? Because you have got, first of all, very good integration with rest of the platform. Few of the new things with ECS are AWS VPC networking mode, where each task will have an identity in the network. Each task will be actually associated, it can be associated with the ENI. You have service discovery through Route 53 right now available on ECS. You have got advanced task placement. Francis is going to cover that as part of his demo. You have a global footprint. For example, ECS is right now available on in Mumbai region, and Fargate with ECS will be available soon here. You have deep integration with the AWS platform. You have got a very powerful scheduling mechanism. In fact, if you can write your own schedulers with ECS, there is there is a open source project called Blocks, which lets you write your own scheduler. You have got an extremely powerful CLI. In fact, two CLIs. One is AWS CLI, which has a ECS mode, as well as ECS has its own CLI called the ECS CLI. In the shared responsibility model, basically in ECS, you let the customer bring their you have as a customer you have to bring the ECS. You are in charge of managing your EC2 instances. You are managing your Docker images, your instance scaling, your operating system within the instance. AWS actually manages whatever is below this horizontal line. Specifically, the ECS control plane is the one which AWS is managing. In Fargate mode, the operating system and the instance scaling is also part of AWS's responsibility. You don't have to bother about that. These are some of the customers who are using ECS. This is a little dated slide. We do have much more than this right now. For example, CleverTap is not yet there, but CleverTap uses ECS. This is a slide from last December. Now I'll go a little bit on the best practices on microservices and containers. First best practice is to basically let AWS and your pipeline handle the changes and the secrets. You should use IAM roles for tasks because your roles otherwise inherit the roles which was given to the EC2 instance. Rather than that, you should actually use IAM roles for tasks. For secret management, you should use either you should use either the parameter store or the secret manager, which is recently released. For any change, you should actually do it through either CloudFormation, or if you are doing Terraform, you should let those changes be done by that. One very important thing is that you should always practice the list privilege policies, so that you one basic rule of thumb would be in in policies you should minimize the use of stars. You should the exact privileges which are needed by IAM role should be absolutely given to that user, and anything more than that should not be given. End-to-end automation, this is very important. So as much as automation is there, it should be implemented, because the lesser you let users touch the pipeline, it's better for you. So you should try to automate the code and container builds, your infrastructure as a code patterns, your deployments, your self-healing, and security. Most of it is you can actually automate this, and you should implement the automation as soon as possible in your environment. Delegate to AWS with higher level services, because what we have seen is you as customer, you don't have to reinvent the wheel always, and building and running fundamental services that are highly available and scalable is hard unless you are a cloud provider like us. So you should let us do what we call the undifferentiated heavy lifting, and you can actually manage your business logic. So ECS AWS already provides these core services, and you can actually use them to help build your business logic, and you can start using them if you are not already doing so. This is very important from a security perspective, also from a performance standpoint. Build small container images, because the larger your image is, you have a large attack surface for attackers to come in. So there are various ways of actually getting your images small. One of them is a multi-stage build. Yeah, you should take your images from a trusted base image, or better is if you can take the Docker file of a particular image from Docker Hub, and then you start building it yourself. You should go for one service per container. The rule of thumb should be that there should be one concern which is addressed in one container. And instead of using latest or numbering as your um, um, image tags, you can use something like the um, checker name or something informative as the image tag for your check-ins, right, which will give you some good information. Decouple your services and teams. And the golden rule is basically you can make a change to a service and deploy it by yourself without changing anything else. I think the better way is to test this is if you can in your environment make a change and you need not talk to any other team about it, then you have passed that test. So it is better to basically have everything decoupled and as independent as possible within your environment. This is just a small example. So this is a picture of a ship getting built in World War II times. You will see watertight compartments separated by walls, and they actually help uh, to contain the flood if at all there is a breach in the ship. Right. Same thing you can actually implement within your design. You have SQS queues between services, and you have APIs will throttle and retries um, exponential retries, which actually acts as a buffer between your services. So even if there is a flooding in one of in your application, your application continues to run in a degraded mode, but there will be nothing like a complete failure, right? Um, there are some simple patterns here. So according to the microservices paradigm, every service should have its own data store. And if it happens that you both there are two services which needs to be talking to to the same database, what you can do is you can actually introduce a service which talks to this database, and the other services actually talks to this particular service. Here you can see that the password service is actually talking to this database, and then to the password database, and your user service and authentication service are both talking to the password service. So we are not letting two services actually talk to the same database. And last thing here is you can always use something like a message queue to make things asynchronous as much as possible. This queue actually acts like a shock absorber, and it brings in asynchronous design in your overall architecture. Here are some resources. We will anyway share this once the presentation is done. Now over to Francis for the CleverTap part.
Thank you, Shibu. Hi, everyone. This is Francis, and I'm from CleverTap. We are a mobile marketing platform that helps growth marketers, essentially. Just to give you a sense of where we are and the kind of scale that we deal with on a daily basis. What you're looking at is the traffic pattern during one of these IPL matches. So the times here are in UTC, but if you do convert that into IST, it's about 7:59, and it looks like we're doing about 5 million HTTP requests per minute as reported by the load balancer. A couple of minutes later, as soon as the match begins, looks like we've almost doubled our traffic, right, at about 12 million per minute. And then from there on, it's all just jerky depending on what kind of match it is, who is playing, and where it is in the match. So that's traffic that we can predict. On the right side, what you can see is traffic broken down by customers. So obviously the green is the customer with the IPL match, but there's also this red customer who shows up and he just does something out of the blue, and that causes this traffic, which is going down, to simply spike up. So all this is hosted on Amazon. We don't have to worry about bandwidth and scaling and getting data transfer sorted out. What I want to talk to you today about is stateful workloads on ECS. So you generally hear about containers in the scheme of stateless web servers deployments, or places where you get some data in from S3 or a persistent data store. You work on it and then you put it back into some persistent state. But mostly these containers are stateless. We do something very, very different. We use these containers to enable stateful workloads. And the motivation behind this for us is because we have this in-memory custom-written database that powers all of our platform. All of the data is in memory. And what happens is when you run out of mem on a machine, on an EC2 instance, the only option that we had in the past was to double the instance size to let the customer grow. And this meant that we just incurred additional costs on behalf of the customer. To solve this problem, we sort of bin pack and place multiple stateful containers on, use ECS to orchestrate this container run across EC2 nodes. So, and I'm going to go show you a demonstration of how you do this, but the basic theory behind having a container run on a specific instance is to put an instance attribute. What you're looking at is a customer defined or a custom instance attribute called cluster.instance identifier, whose value is a mashup between the cluster name and the EC2 instance. So the stateful containers on ECS Bitbucket cluster, that's the name of the cluster itself, and the EC2 instance is called Bitbucket EC2 instance. So while I told you that we run a custom-written database, it's not really fun to see that in a demonstration. So what I'm going to show you today is Atlassian's Bitbucket. For those who are not familiar with the Bitbucket, Atlassian has a Git repository management tool, very similar to GitHub, which is hosted on bitbucket.org. And there's a self-hosted solution. They provide a Docker container, which is hosted on on Docker Hub. And today we're going to run that container as a part of the demonstration. So back to our strategy of pinning these containers into a specific EC2 instance where your data is. Once you have the instance attributes in place on an EC2 instance, you set a task definition to essentially, you constrain it to run only on an instance where the cluster.instance identifier is equal to the name, the unique name that you gave it by mashing the container, the cluster identifier and the EC2 instance. So let me show you what this looks like in real life. This is the EC2 application that we're trying to sort of run statefully on ECS. It's currently down, it's not working. And I'm going to show you that we've got these 4 EC2 instances inside a cluster. All of these instances have been added here, if you take a look at it. And obviously the worry over here is that when I start up this task, or when I start up this container, it could go randomly run on any one of my instances, and those instances may or may not have my data, might look like fresh install. So let me start a task for you. This is my task definition for the Bitbucket hosted product from Atlassian. There's nothing very special about it. It's a simple container that I'm saying from Docker Hub. It exposes a bunch of ports, but what is special about it is the constraint here, which says that it must be run where the instance attribute is cluster identifier equals to this long string. So let me just start this up. Sorry. The strategy in this case, when you're trying to pin containers to EC2 instances, doesn't really matter because you're running mostly one container per instance, and that you technically aren't have them across two instances. But the constraint is the real key here. So I'm going to boot up this task. It tells me, ECS tells me that the task is now running. Let's go and see what happens to our application. Come on. Still pending, running now. Voila, there we go. For a minute, I thought that wasn't going to come up. So that's Atlassian's Bitbucket. It's booting up. I have created a couple of repos in there, so we can make sure that that's the exact. We are on an instance where our data exists, and then we can go turn it off, do some fun things along with it, and see that data consistency remains even if you try and kill the EC2 instance, shut it down. The task won't randomly start up elsewhere. So you basically are able to tame a task or a container to a specific instance. Still booting up. There we go. So I have a project called CloudFormation, and this is a Git repository that I'm now hosting on my own EC2 instance. It's running from the task that we just started. And just like that, you take a container out of Docker Hub, you can run it yourself on EC2. Let's try and play with this a little bit. So we stop this container. And we shut down the EC2 host that was associated with it. So the EC2 node holding my stateful data is now going offline, and my container is down. My application is dead again. Yeah, it doesn't seem to connect anymore. Let's see what happens when you try and run this container without the EC2 instance that we pinned it on. So we're saying the same task definition and the same cluster. Give me one instance of the task running. Oh, that's a big red. So we are failing constraint, which means that the EC2 instance that was supposed to be there is no longer available, and our task is not randomly starting up on the other container instances that I have where data isn't present. So let's go back and turn this container back on. Sorry, the EC2 instance back on. So waiting for this to come up. All right. Is the container running? Is it a part of the cluster already? Yep, looks like my instance is in based on this value reported by the agent connected true. Sorry. Yes, I'm trying to run that again. Voila. And now that the EC2 instance is back where your data exists, the task definition seems to be happy to run. Seems to be running. Let's look at our application again. Oh, there it is, back. Let's see. Let's log in and see if you still have a repository there, or is it gone from a container restart? My colleague here says fingers crossed. All right. So booting up. So these stateful applications that you run on ECS aren't the microservices that Shibu was talking about that start up really, really fast. These are databases, these are applications that run for longer periods of time. So they do genuinely take longer to boot, just like Atlassian's Bitbucket, which is still booting up. But we should have it in a minute or so. Started. What do we have? Oh, a repository still exists, and the CloudFormation thing that we set up, the CloudFormation repository that we created is still there. All of our settings are there, and it logged me in too. It knows I am Francis. So looks like we are persistent. Yes. So that's it. One simple trick to lock your instances down that enables stateful workloads that have persistent data on EC2. Makes it very, very easy to orchestrate the stuff with ECS. Let's go back. So that was our demonstration. If we have, and if time permits, I will take questions if you have. So putting this all together, how we do this is what we've learned from our experience is that you run one container per task. That's the standard recommendation in the Docker world. In the ECS world, what you do is you only tell it to run one task. The number of tasks is always set to one, because since you're locking it to a specific instance, you technically cannot run two tasks of the same thing. And then you can wrap this task around a service. So a service monitors container health, and if the container exits or stops responding, it can do a restart for you. Services support any arbitrary configuration that you may have. So you can just tell it that I want to go, hey, ECS, go run this command for me inside the container. And as long as that exits successfully, it's all good. So you're free to do whatever you want in that command. It could be a bash, it could be whatever. It could do all kinds of funky things. It could take stack traces if in case of a failing service, stuff like that. Also, what it does is that you no longer have to wake up in the middle of the night to restart a container. That just, you can hand it off to ECS. What we've thought is very, very important is that when you're doing something like this, you have to version control and manage all this configuration, these tasks and the little properties that go with them, and the placement strategies, constraints from CloudFormation, which is version control. Without that, a kind of easy to get lost in the whole thing. What changed when, what mapping was changed, what container was moved from an EC2 host to another EC2 host. All of that can become really daunting if you're not very careful. So our tool for resource provisioning is CloudFormation, and we recommend that you use either CloudFormation or Terraform, whatever floats your boat, to keep track of changes that you make into these containers and ECS. The other thing that we realized is that you would imagine that you could just shut down a container instance, change this instance type, and bring it back up. But if you do that, the ECS agent goes completely nuts, and it's kind of spitting out in the log that you got to go back and register it as the same instance type that you initially registered it with. So if you ever want to change your container instance, you have to move your data or take that volume, attach it to a new EC2 instance, and update your placement constraints to run it on a different box. By the way, if you're passionate about systems engineering, automation, and infrastructure as code, drop us a line. We're based out of Mumbai and are available at jobs@clevertap.com. Back to you, Shibu.
Am I audible? Yeah, thanks, Francis. So we'll do some other customer case studies. First in that, we'll cover a customer called GoPro. So GoPro makes these amazing cameras, and this is the infrastructure they have on ECS. They use S3, SQS, ECS, and Elastic Transcoder. Consists of more than 40 services in production. Their ECS infrastructure consists of 40 services in production that processes up to around 500,000 API requests per minute. And moving a batch to ECS took them under a quarter. Um, and moving to ECS reduced their EC2 footprint by 70%. If you remember my one of my earlier topics I covered, if you are really interested in actually bringing down your EC2 cost, you might actually do bin packing of your containers, and that can drastically reduce your number of EC2 instances you use to manage your workloads. Uh, I will give you links for the talks which GoPro has done in reInvent. You can go and actually listen to it and have a look at their architecture. We are just going through the architectural advantages they took when they came to ECS. So they didn't need to build or operate a container orchestrator or queuing service. This was already provided in form of SQS and ECS. The use of S3 and Elastic Transcoder further delegates their scaling and operational challenges to AWS. So this is the undifferentiated heavy lifting I was talking about. If you have things which you can offload to AWS, you can always do that, and you can actually concentrate on your core business. And their architecture is built with asynchronous pattern where customer requests and edits are notified when done. So they did actually decouple the app and API from for the batch processing. The architecture is well described in one of the links I'll be giving further in this session. And as I described earlier, also the queue gives them a shock absorber and time to scale. So in a way, they basically made this whole thing asynchronous by using queues between the services. Some of the lessons GoPro learned was basically leave a buffer of around 20% capacity when auto scaling up or down based on the CPU reservation. This is extremely important because containers can come up pretty fast. So you might have a situation where your service is getting auto scaled at a rate which is much higher than your container instance, that is your EC2 auto scaling rate. So you might have to keep, it might be a good practice to keep a 20% buffer in your EC2 EC2 fleet, just that if your services auto scale at a higher rate, they will have a EC2 instance to be hosted on. Execute the Terraform to manage the cluster from a control pipeline rather than from a developer laptop. So this is also something we covered. The idea here is to manage the cluster through something like they were using Terraform. You can use CloudFormation template also here. So manage it through CloudFormation templates rather than each individual going and changing a part of the pipeline on their own, and because it becomes extremely difficult to track those changes. Last thing, I think one of the lessons they learned was decouple the Terraform infrastructure as a code sections to limit the blast radius. This is extremely important. You always should try to isolate failure zones so that if there is one failure, that should not bring down the whole application. Even if it might actually lead to your application running in a degraded mode for some time, but still there will be no complete failure, and you can actually go and repair your failure. So restricting the blast radius to a small change is extremely important. These are some of the videos and reference links we'll be sharing as part of this presentation. Next case study is Expedia. Expedia is a well-known company, and they're one of our largest referenceable customers who have, and this is a little dated figure. So they had around 1,110 applications across 2,600 ECS services. They had around 13,000 containers across 860 EC2 instances. These are the container instances, and all total they had around 13 ECS clusters spread across 5 regions, and they had 524 deployers per day to do the testing. They have this platform called Primer, which makes it very easy for the developers to generate microservices and then deploy. And it allows you to do controlled changes and deployments, and consistently and it allows you to generate consistently operable services, right? um, Lessons which AWS and Expedia jointly learned during their operation with ECS was that you should be cognizant of your limits, because if you are not if you do not know that if you are about to hit a service limit, it can be dangerous, because typically service limit increase might take you some time, and that might hinder the for example, auto scaling of a service. So you should be aware of your limits at all time, especially the ECS number of services per cluster, ECS container instance registration rate, or your EC2 API throttling. Um, be aware of auto scaling thrashing. This is also very important. So what? So one analogy you can draw here is you want your auto scaling to be like a sprinkler. When there is a fire, you want your sprinkler to be switched on immediately, but when the fire is gone, the sprinkler should immediately switch off to basically avoid a situation of flooding. Exactly, that's what was happening in Expedia for a while. Um, they would actually scale up on a certain parameter. How it is described here, would see it scale up due to high memory reservation, and then immediately they have to scale back down due to low CPU reservation. So it took them some trial and error to figure out that sweet spot, right? So better if this stage is attended earlier in the process. You figure out a sweet spot for your scale out and scale in thresholds, right? So it's extremely important to have that ready. And um, links to the videos which we have with Expedia are here. They have spoken in our reInvent, and the case study is also there, along with the lessons and their architectures. So in summary, how to operate containerized microservices at scale. um, Use IAM roles. You can use secret managers like the recently released secret manager, or parameter store from SSM, or you can use HashiCorp's Vault, but you must use a secret manager to manage your secrets. Delegate to AWS for higher level service. You don't have to reinvent the wheel. Uh, Offload tasks which are not directly related to your core business logic to AWS. Let AWS handle it. Um, Build small and secure container images. Extremely important. You should have your images coming from a trusted source. You should have container images as small as possible, because that affects your cold start latency. If you have a big image, it takes more time to pull it from the registry and get started. You should have small images. Not only that, your attack surface reduces. Decouple your services and teams, very important. um, the part teams is extremely important, so that um, you don't have to, if you want to change a particular service, uh, the team related to that service should not have to ask any other team before or after doing that change. It should be fairly independent. And invest in end-to-end automation. This goes a long way. as much as automation you can bring, the less human intervention is there in your whole pipeline, it is less prone to problems. And very important that you should make it easy for your team to do the right thing. So as you should make your team aware of the best practices for container deployment and ECS management, and it should be quite easy for them. They should know what a good thing looks like. For example, if they are deploying their microservices, and they should know how the VPC should look like, right? And it should be extremely easy for them to go and find how a good thing looks, and it should be easy for them to deploy and implement as well. So get started today. It's very easy to get started either on ECS or on Fargate. We have the tools and resources that can help you out. Uh, One of our colleagues, Nathan uh, Nathan Peck, has a site called Awesome ECS, which has a lot of good links and videos and tutorials for you to get started. You don't have to do it all at once. So pick up one area or set of teams to decouple and containerize and get started today. So that's it from my end. Any questions? Yeah, so Rohini, I'll ask her to read out questions, and we cannot answer all of them, but some of them we can definitely try to answer.
Yes, so we have a lot of questions on the site, so we'll try and pick and choose some of them with the time remaining. The first question would be, I think someone missed out the start, so we can answer this quickly. Do you recommend to move ECS only for large applications based on microservices architecture, or even for small web applications can move to ECS? And if yes, then what's the advantages?
Okay, so we have customers who are running huge applications on ECS as well as small applications on ECS as well. But by huge applications, I don't mean a container with image of 1 or 2 GB. You should ideally you should always break down containers in applications into smaller containers or services and then deploy it, and try to make it try to accommodate only one concern or one functionality within a container. So ECS is a means of running your containers, your Docker containers efficiently. As long as you have a Docker container, we can run it. As far as best practices go, you should restrict the amount of functionality you put in a container. Also remember that the container lifecycle should be tied tightly to the application lifecycle. That means when the application has to stop, the container can also stop. If you put more than one application in a container, it might happen that one of them has stopped, but the container cannot stop because there are others which are still running. Rohini.
No, thanks for the answer. Okay, so how do you make sure that when you're scaling down a services task, that it doesn't get any request to process just before scale termination? So how do you ensure the draining of that task itself?
So in ECS, when you actually mark a container instance for draining, automatically no new tasks will be actually scheduled on that container instance. Yeah, ECS control plane makes sure that all tasks are going to the instances which are in the non-draining status. And there is a very nice blog on automating your draining container instances, where you can use a Lambda to make sure that a container instance has completely drained, and this Lambda can be tied to a lifecycle hook of the autoscaling group, and once it is completely drained, it can actually tell the autoscaling group to terminate the instance completely.
Okay, great. I think this question would be for Francis. Is that a good idea to run a database inside a container?
If we have massive amounts of data that we sort of put inside a container, but ours is a custom written database or a data store. And I think there's a shift with what's happening. Previously, a databases is something that you would deploy once and then forget about it for years. But in our case, this is the core of our business. So we have incremental updates to the database going quite often, which is why it makes sense for us to deploy this as ECS as containers in ECS.
Okay, thanks, Francis. I think there's one question which may not be in the context, but it's a question that I've been seeing. Can you explain one difference between ECS and EKS, and why would we choose one or the other?
Both are great container orchestration systems. Both can help you running your container Docker containers. EKS is a managed Kubernetes service. EKS lets you run your containers on a Kubernetes cluster. We manage the control plane as we are doing for ECS. ECS is something which came out from AWS in the year 2015, and we have actually brought in a lot of resources, a lot of innovation to the platform. EKS is top of the trunk, pure Kubernetes experience, just that we are managing the control plane for you. As far as running your workloads, there is not much difference. Both can run your workloads quite efficiently, and as a user, it should not be much of a difference to you. In fact, EKS is also quite soon be integrated with Fargate, which would let you run EKS in Fargate mode also. So from a user point of view, not much of a difference. But yes, there are some use cases where you might have to use EKS. For example, if you have an on-prem workload, since Kubernetes can be running on your on-prem infrastructure also, it might be easier for you to move to EKS rather than ECS if you already have a workload running on a Kubernetes running on-premise.
Thanks. So I think that also answers the question about Fargate. But if you have anything to add about Fargate, we have a lot of people asking about how does Fargate fit into the ECS and EKS world.
Yeah, Fargate is a pretty interesting addition to our container services. Fargate is somewhere in between your completely serverless implementation of microservices versus your containerized implementation of microservices. Fargate lets you not worry about your container instances or the EC2 instances at all, because you as a user are only responsible for your Docker images which you bring to our platform, and it first of all gives you the one less thing to worry about. Second is you don't have to worry about auto scaling your underlying EC2 instances at all. It almost gives you a unlimited playing field for your service to be auto scaled. So just to elaborate a little bit on that, you have two types of auto scaling in a ECS cluster. You have your auto scaling for your EC2 instances, as well as you have auto scaling for your services. In Fargate's case, you don't have to manage the auto scaling of the EC2 instances at all. You have to just manage the auto scaling of the service which constitutes of your Docker images. Not only that, you can be rest assured that your services are always running on the latest ECS optimized AMI, and that way they are secured. There will be no backdoor entry to those instances, which you might have missed when you are managing your own cluster. So these are the basic things which Fargate brings. Not only that, there is a difference in the pricing model also. In Fargate, we charge you for the compute resources your container uses, rather than letting you pay for the complete cluster. In ECS also, we don't charge you for the control plane at all, but you have to pay for your EC2 instances, even if your EC2 instances are not optimally utilized. But in Fargate, you have the option of paying just for the CPU cycles and the memory you use for your containers.
Wow, Shubhu, you're actually anticipating the questions here. So that's nice. You also answered the price perspective over here. I think the next question, and
We can take
probably
one
it
last
would be
question.
last question, yes. Yeah, so that would be for maybe Francis. Can you help us a few use cases, maybe a couple of use cases related to automation on this topic and how it has helped you?
So our primary tool for automating all of this is CloudFormation. So it's all immutable. There is no configuration management. If there's anything we want to do inside the ME, we choose to use CloudFormation init, which does a basic setup if there's anything that's required. But mostly, this is all Dockerized. The application's environment is inside the container, and the EC2 instance just becomes a unit of compute. We truly don't care about it so much. So whatever there is to configure in there, we would bake it into the ME, and then just have the ME run from cloud by ECS. And all of this configuration, again, is put together with CloudFormation. This is how we track changes. This is how we make any change within our platform. We never go into the console. In fact, for us at CleverTap, we don't even have write access into the console. All we can do is certain start, stop, task kind of things, but we can't change anything fundamental within the AWS infrastructure without having to go through CloudFormation, get it reviewed, and then deployed via code pipeline.
Thanks for that, Francis and Shubhu. And thank you everyone for attending this webinar. We definitely have a recording available on our website, and we'll have a follow-up on that later. So thank you guys. Have a good day.